Okay, so we do question 15.3 now. So 15.3, giving you a demand function P equal to 1 minus Q. Let's see I be the cost of production, so basically the marginal cost or the average cost for firm I. Cost of production ECI. Okay, so for each of the firm they will be having a different cost of production, so a different marginal and the average cost. So part A of the question telling you that calculate a Nash equilibrium quantities, assuming that we have two firms in the market, and then compute the market output, market price, and profit for each of the firm, and the profit for the industry, the consumer surplus, and the total welfare. Okay, so we have two firms outside. We have firm 1, and the cost of production will be C1, and firm 2, where the cost of production will be C2. Both of them as facing the linear market demand here. Each of them will be producing Q1 and Q2 respectively, and the total quantity in the market will be equal to the quantity produced by firm 1 plus the quantity produced by firm 2. Okay, so now we find the Nash equilibrium. So in the Nash equilibrium, each of the firm will be choosing the quantity in order to maximize the profit, and they will be doing that simultaneously. So we do for firm 1 first. So firm 1 will be maximizing the profit for firm 1 by choosing the quantity Q1. Okay, and again, in order to maximize the profit, they will just have to set the marginal revenue equal to the marginal cost of firm 1. Very similar to the to question 15.2, 15.1 that we did before. I will just be going through it again. Now, in order to find the marginal revenue for firm 1, first of all, we just have to find the total revenue for firm 1, which is equal to the price multiplied by the quantity produced by firm 1. Now the price is equal to 1 minus the total Q, and the total Q, which is equal to Q1 and Q2 together, multiplied by Q1. So if I expand everything, I will find that it equal to Q1 minus Q1 squared minus Q1 Q2. Okay, so knowing the total revenue as a function of Q1, I will be able to find the marginal revenue by differentiate the total revenue 1 with respect to the quantity Q1. And if I'm doing that, I will be able to get 1 minus 2Q1 minus Q2, and that is the marginal revenue for firm 1. Okay, so I already found the marginal revenue. I will just have to substitute back into my equation where marginal revenue will have to be equal to marginal cost, and I will get marginal revenue equal to 1 minus 2Q1 minus Q2, and it has to be equal to the marginal cost, which is equal to C1 in this case. Again, the idea is firm 1 choosing Q1, taking Q2 as given, so firm 1 doesn't have any powers to affect Q2. So they will be treating Q2 as a number and choosing Q1 in order to maximize the profit. So in order to write the equation, you will have to divide the quantity of Q1, because that's the thing the firm 1 can do. Okay, that's the variable that firm 1 can choose in order to maximize the profit. So Q1 will be equal to 1 minus Q2 minus C1 divided by 2. Okay, so that will be 1 minus C1 on 2 minus half of Q2. Okay, so given the amount of Q2, Q1 will be chosen according to this equation in order for the profit of firm 1 to be maximized. So this is the first equation, and this is called the best response function of firm 1. Right, so we do very similar thing for firm 2. Firm 2 again, we should try to maximize the profit of firm 2 by choosing the quantity Q2. So the firm again, which is set marginal revenue equal to the marginal cost for firm 2. So we do very similar thing like what we did to find the marginal revenue for firm 1. Doing the same thing, you will be able to get marginal revenue for firm 2 equal to 1 minus 2Q2 minus Q1. And it will have to be equal to the marginal cost of firm 2, which is equal to C2 in this case. And therefore, Q2 will be equal to 1 minus C2 minus Q1 on 2. And that which is equal to 1 minus C2 on 2 minus half of Q1. Okay, so given the amount chosen by the first firm, second firm will be choosing Q2 according to this equation in order to maximize the profit. So this is called the best response function of firm 2. Okay, so again, just like what we did before, we have two equations, two variables. Solving for a system of two equations, you will be able to find the values of Q1 and Q2. Okay, so we're solving for first and the second equation together. Again, easiest thing to do is to substitute one into the other. So I'll substitute the second into the first. Then I will be able to get Q1 equal to 1 minus C1 on 2 minus half of Q2, and Q2 which is equal to 1 minus C2 on 2 minus half of Q1. Okay, so now as you can see, we have an equation which only include Q1. So solving this equation for Q1 is easy. Okay, so I'll rearrange it. I'll expand everything first. So I got Q1 here on the left hand side still there. 1 minus C1 on 2 minus 1 on 4. 1 minus C2 and plus 1 on 4 Q1. And if I move every Q1 to the left hand side of this equation, I will be able to get 3 on 4 Q1 equal to this is half. This is minus C1 on 2 minus 1 on 4 plus 1 on 4 C2. Okay, and half minus a quarter, which is give you a quarter. Negative half C1 okay, so negative half of C1 plus a quarter of C2. So that would be plus a quarter C2 minus 2C1. And therefore, if I multiply 4 in both sides of this equation, I'll get 3Q1 equal to 1 minus 2C1 plus C2. And therefore, Q1 will be equal to 1 minus 2C1 plus C2, the whole thing divided by 3. Okay, so this is the amount of Q1 going to be produced by firm 1 in order to maximize the profit of firm 1. So as you can see from this function here, Q1 is a function of C1 and C2. So if you know the cost of production for firm 1 and firm 2, you can just substitute the number in, you will be able to find the value for Q1. Okay, so in this case, this is the general form given the general cost of production C1 and C2 by both the firms. Right, so knowing the amount of Q1, so I'll put a star here to indicate that it's equilibrium. Using the second equation, you will be able to find Q2. So your Q2 is equal to 1 minus C2 on 2 and minus half of Q1. So I will just substitute the values of Q1 in here. I will be of Q1 star in here. I will be able to find Q2 star. So that is 1 minus C2 on 2 minus half of 1 minus 2C1 plus C2 on 3, and I will just have to expand everything and then rearrange it to simplify it. I will be able to find the amount of Q2 star in this case. So I'll get the I'll make the common denominator is 6. So I will get 3 minus 3C2 minus 1 plus 2C1 minus C2. Okay, everything on 6. Now I simplify this. I will get 3 minus 1 E2, negative 3 C2, negative 1 C2 is negative 4 C2 plus 2 of C1, and the whole thing on 6. Simplify this, I will get 1 minus 2C2 minus plus C1 on 3. Okay, so this is the quantity going to be produced by firm 2 in order to maximize the profit of firm 2. What is the total quantity in the market? So the big Q, so I'll call the big Q star, which is equal to small q1 star plus small q2 star. If you add them up together, you get 1 minus 2c1 plus c2 plus 1 minus 2c2 plus c1, and the whole thing divided by 3. You will be able to get that equal to 2 minus c1 minus c2 on 3. Okay, so that's the total quantity going to be produced in the market. Knowing the quantity, you will be able to find the price in the market, which is equal to 1 minus quantity. So it's 1 minus 2 minus C1 minus C2 on 3. That will give you 1 plus C1 plus C2 on 3. Okay, so that is the market price. The firm profit. So we want to find the profit for each of the firm. So the profit for firm 1 will be equal to the price minus the average cost for first firm, which is basically C1, and multiply by Q1 star. So we know the price equal to 1 minus C1, 1 plus C1 plus C2 on 3, and then minus C1, which is the average cost of production for firm 1, and multiply by the quantity produced by firm 1, which is 1 minus 2C1 plus C2 on 3. That will give you, so the first bracket, if you multiply 3 into C1 to make the common denominator become 3, you will get that equal to 1 minus 2C1 plus C2 on 3, and that exactly equal to the thing in the second bracket. So if you multiply them together, you will get that square. Okay. Similar, the profit for firm 2 is equal to the price minus the average cost of firm 2, which is C2, multiplied by the quantity produced by firm 2, which is Q2. The price is 1 plus C1 plus C2 on 3 minus C2 multiplied by the quantity produced by firm 2, which is 1 minus 2C2 plus C1 on 3. And if you do the thing inside the first bracket, you will see that it will be giving you the same thing as the thing inside the second bracket. So that will become 1 minus 2C2 plus C1 on 3, the whole thing square. Okay, so that's the profit for each of the firm. The total profit in the industry will be the profit of the first firm plus the profit of the second firm. And that will just, so we just have to add 2 squared together. Plus C2 plus C1 on 3 square. Consumer surplus. So knowing the price and the total quantity going to be produced in the market, you will be able to find a consumer surplus. Right, so in terms of the graph, it's going to be, so you have like this, price here, quantity here, market demand is here, where this equal to 1, this equal to 1. Know the quantity produced and knowing the price in the market, the consumer surplus gonna be the area here, okay, the small triangle area above the price and below the demand curve. So the consumer surplus, I'll put the consumer surplus star to indicate that in the consumer surplus in equilibrium will be equal to half of 1 minus P star multiplied by Q star. Okay, so knowing the values of P star and Q star, you will be able to find the consumer surplus, which is half multiplied by 1 minus the price E1 plus C1 plus C2 on 3, and the total quantity produced by both of the firm is two minus C1 minus C2 on 3. Okay, so this is half. The first bracket will give you 2 minus C1 minus C2 on 3, and which is exactly the same thing as the thing inside the second bracket. So the consumer surplus, which is half of 2 minus C1 minus C2 on 3 square, and the total welfare. Now total welfare, which is equal to the consumer surplus plus the total profit in the industry. Okay, so knowing the consumer surplus, which is equal to half of 2 minus C1 minus C2 on 3 square, knowing the total profit in the industry, so I should have a star here. So the total profit equal to 1 minus 2C1 plus C2 on 3 square plus 1 minus 2C2 plus C1 on 3 square. So that will be the total welfare in the market. Okay, so we're done with part A. Now part B represent the Nash equilibrium on the best response function diagram. So we've tried to show the best responses function for both the firms on the diagram, and then see how reduction in the cost of production for firm 1 will change the equilibrium. Okay, so we'll have something like this. Okay, so this is the price. Sorry, we have a diagram of the best response. So that should be Q2 and this should be Q1. Okay, so we want to see how each of the firm will be responding to the quantity decision made by the other firm. Right, so we got best response function of firm 1 like we found before. So Q1 is equal to 1 minus C1 on 2 minus half of Q2. Okay, and best response function of firm 2 is Q2 equal to 1 minus C2 on 2 minus half of Q1. Okay, so we're going to be drawing, now remember Q2 is on a vertical and Q1 on a horizontal, so it will be easier to draw the best response function for firm 2 first. So I will be doing for firm 2 first, where Q2 is already on the vertical and is already the subject here. Right, so the vertical intercept for the best response function for firm 2 will be 1 minus C2 on 2, and the slope will be a half. So I'll make it here 1 minus C2 on 2, and the slope will be equal to a half, so it will be something. So say we'll have something like this. Okay, so the slope equal to a half, the vertical intercept, and this is the best response function of firm 2. Okay, now I do the best response function for firm 1. Now remember Q2 is the vertical is on the vertical axis. So in order to draw the best response function for firm 1, easiest thing is to rearrange the best response function here to make Q2 as a subject, because I want Q2 on the vertical. So if I rearrange this thing here, I got Q2 will be equal to 1 minus C1 minus 2 of Q1. So 1 minus C1 will be the vertical intercept, and the slope of the curve will be negative 2. So I will have 1 minus C1 somewhere here, for example, and the slope will be equal to negative 2. Okay, so we'll have something like that. So this is the best response function of firm 1. Now remember, I draw 1 minus C1 is bigger than 1 minus C2 on 2. This is the necessary condition in order for the equilibrium to exist. Now if 1 minus C1 is smaller than 1 minus C2 on 2, then you will have a curve somewhere like this and it's going down, so there won't be any intersection between the best response functions of both of the firms, and there won't be any equilibrium. Okay, so the condition in order for the equilibrium to exist is 1 minus C1 will have to be bigger than 1 minus C2 on 2. So here is the equilibrium where both of the best response functions are cutting each other. So this is called the Conant-Nash equilibrium. Okay. Right, so now if we have decrease in the cost of firm 1, as you look at the best response function for firm 2, there isn't any C1 in there, so the change in C1 doesn't change the best response function for firm 2, so the line will be still the same. The only thing will be changed is the best response function for firm 1. Okay, so if C1 is smaller, you will have a reduction in C1. 1 minus C1 will be bigger. Okay, so the whole stuff will be bigger, and therefore the vertical intercept will be bigger. Okay, while the slope is still the same, so negative 2 is still the slope, so the new best response function will be shifted to the right of the original best response function of firm 1, and it will have to be parallel to the old one. Okay, so only the vertical intercept is higher, but the slope is the same, so the curve will have to be parallel and shifted outward. So I'll be doing that. I'll draw a red line. Oops. Okay, so I'll be doing a red one. I'll make it parallel to the old one, and then okay, so this is my new best response function for firm 2. Sorry, for firm 1, which is higher vertical intercept. So that is 1 minus C1 dash. Okay, so it's C1 dash is smaller than C1 because we have a reduction in the cost of production of firm 1, and so the best response function will be shifted outward and parallel to the old one. Okay, so you can see the new equilibrium now is this point here where we have a new intersection. Okay, so we have a new equilibrium. As we can see from the graph, the new equilibrium basically specifying a higher level of Q1 and a smaller level of Q2 in equilibrium. So firm 1 will be able to produce more, and firm 2 will have to produce less in the equilibrium. Okay, so the reason for that is because firm 1 is becoming more efficient. The cost of production is lower. So in the competition with firm 2, they will be having more advantage. And they will be able to produce more in order to capture more profit compared to whatever they could have done before. Right, so in the new equilibrium, the quantity for firm 1 will be higher, and the quantity for firm 2 will be smaller. Okay, question also asks you to draw an isoprofit curve for firm 1. Okay, so isoprofit is the curve telling you on the combination between Q1 and Q2 that will give firm 1 exactly the same amount of profit. So I will draw an isoprofit curve for firm 1. So it will be having something, so it will have to be, so I draw the isoprofit curve corresponding to the own cost of production to corresponding to C1. Okay. Okay, so this is the isoprofit for firm 1. Okay, now remember the maximum point of the isoprofit will have to be going through the best response function for firm 1. Okay, remember that is the best response function, so that is where the profit for the firm will be maximized, given the firm are choosing the quantity according to that best response function. So the best response curve will have to be going through the maximum point of the isoprofit. Okay, so the isoprofit here, for every point on that isoprofit, the firm will be getting the same level of profit. And the lower the curve, the higher profit is gonna be for firm 1. Okay, so moving toward the horizontal axis, the profit gonna be higher for firm 1. So lower the isoprofit curve, the higher the profit.